Tonight, we're going to look at something that feels like pure fiction, but may have roots in real science. A wormhole. You've probably seen it in Stranger Things, shown as a tear between worlds. Scientists also talk about ideas like this when they study space and time. But here's what most people don't think about. The show didn't invent this idea from nothing. There are real theories that describe tunnels through space, paths that could link far places in ways that seem impossible. When you start to understand what a wormhole is meant to be, when you see how the math and physics try to explain it, it changes how you look at that story on screen. This is not just a cool plot device. It's a concept so strange that it sits right at the edge of what science can explain. And by the end of this journey, you're going to understand why scientists talk about wormholes at all, and why building one may be far harder than fiction makes it seem. Before we go any further, if you enjoy deep and thoughtful breakdowns like this, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it helps this work continue. Now, let's begin. Hawkins, Indiana, a small town nestled amid the quiet woods and rolling hills of the Midwest, appears on the surface as any ordinary American town might. Its streets are lined with familiar houses, schools, and small shops. And yet, beneath this ordinary facade, Hawkins harbors a secret. In the center of town, the Hawkins National Laboratory looms with its cold, sterile architecture. It is here that scientific curiosity intersects with the unexplained, where the boundaries between known reality and the unknown are tested, often with consequences that ripple far beyond the laboratory walls. The lab's presence transforms the town into more than a backdrop. It becomes a stage where the impossible is made tangible, where the ordinary collides with the extraordinary. The streets, parks, and homes of Hawkins are quietly influenced by the activities within the lab, from unexplained power outages to strange occurrences along the rivers and wooded areas surrounding the town. Even the town's geography, its proximity to forests and small lakes, seems to play a subtle role in shaping the events that unfold, providing natural concealment for the lab's experimental reach. This juxtaposition of the mundane and the extraordinary sets the stage for understanding the phenomena that begin to emerge as the narrative of Season 5 unfolds. In Season 5 of Stranger Things, Hawkins is no longer merely a setting. It becomes a nexus, a point of intersection between the known world and the mysterious Dimension X. The Upside Down, previously introduced in earlier seasons, is an alternate dimension that mirrors Hawkins, but is distorted, darkened, and filled with unknown biological and physical properties. In this season, Dimension X extends the concept of the Upside Down, pushing the boundaries of what viewers and characters understand about parallel realities. Dimension X exhibits properties that defy conventional physics, with shifting landscapes, altered gravity, and strange energy flows. It is populated with forms of life and energy that behave unpredictably, challenging the perception of space and time within the narrative. While Hawkins exists within familiar coordinates, Dimension X overlays it like a second layer of reality, coexisting in the same spatial framework but governed by different laws. The season portrays this space as a realm that can be accessed, albeit with difficulty, through portals or rifts that are thin threads of connection between realities, a concept inspired by theoretical physics, yet adapted for narrative purpose. The idea of alternate dimensions has long been a subject of scientific discussion. In physics, Theories of parallel worlds, or the multiverse, suggest the possibility of realities existing alongside our own, each governed by its own set of physical laws. While these theories are abstract and largely mathematical, Stranger Things gives them tangible form. The Upside Down and Dimension X operate as visual and experiential representations of these ideas, allowing the characters to navigate and interact with them. Dimension X, in particular, amplifies the danger and unpredictability associated with these alternate spaces. Its existence raises questions about how such a space could be connected to Hawkins, and whether it is a natural feature of the universe or a creation influenced by human experimentation. The narrative suggests that the boundaries between the worlds are delicate, vulnerable to disruption, and capable of causing cascading effects in the familiar world when breached. In Hawkins, the National Laboratory becomes the focal point for these disruptions. Scientific experimentation conducted there is aimed at understanding the boundaries of consciousness, psychic potential, and the limits of physical reality. In T-Site Season 5, the lab's experiments have extended to probing deeper into the nature of Dimension X, attempting to locate stable points of contact, map its structure, and observe the flow of energy and matter across its borders. The methods include advanced sensors, containment fields, and devices that measure fluctuations in local space-time, electromagnetic disturbances, and quantum anomalies. These instruments detect variations that are imperceptible to human senses. Yet they indicate that the boundaries separating Hawkins from Dimension X are permeable under certain conditions. The narrative shows how these experiments, while grounded in scientific principles such as measurement, observation, and controlled manipulation, inadvertently create vulnerabilities, allowing rifts to form. The portrayal is consistent with the idea that high-energy experimentation, especially on the quantum level, could interact with unknown dimensions in unpredictable ways. The sensory portrayal of Hawkins in Season 5 reinforces the scientific underpinnings of the story. Sounds become amplified in moments near rifts, with electrical hums, low-frequency vibrations, and sudden silences marking the presence of interdimensional influence. Visual cues, such as subtle distortions, flickering lights, and shadow movements, are presented as measurable phenomena that indicate a nearby breach. The atmosphere of the town shifts in these areas, with temperature fluctuations, sudden changes in air pressure, and chemical anomalies, providing additional layers of sensory data. The characters respond to these changes with caution and observation, documenting occurrences and cross-referencing them with lab readings. This approach mirrors the scientific method, emphasizing measurement, replication, and cautious inference. In this sense, Hawkins itself becomes a laboratory, a field site where the extraordinary can be observed in a controlled, albeit tense, environment. The residents of Hawkins, both aware and unaware of the true nature of these events, form the human context for the phenomena. Characters like Eleven, Mike, Will, and others serve as intermediaries between the familiar and the alien. Their experiences of Dimension X are filtered through perception, memory, and emotion, providing insight into how humans interact with spaces that operate under different rules. Season 5 emphasizes the importance of human observation in understanding the Upside Down and Dimension X. Characters track patterns, predict movements, and test hypotheses, whether consciously or instinctively. Their interactions are shaped by both fear and curiosity, demonstrating that even in the face of incomprehensible phenomena, human cognition seeks to impose structure and understanding. In this respect, Hawkins and its inhabitants function as both a setting and an instrument of study, bridging the narrative with the conceptual framework of scientific exploration. Dimension X, as depicted, presents unique challenges to measurement and comprehension. Unlike the Upside Down, which mirrors Hawkins with darker coloration and biological alterations, Dimension X appears to have its own temporal and spatial irregularities. Objects may move differently, gravity may shift subtly, and energy behaves in ways that defy prediction. The laboratory instruments designed to monitor these anomalies report readings that are inconsistent or seemingly impossible, suggesting that the physics of this space do not align with the conventional laws experienced in Hawkins. These irregularities form the core scientific intrigue of Season 5, as characters attempt to understand whether the dimension is a naturally occurring parallel reality, a side effect of the laboratory's previous experiments, or a combination of both. By representing these phenomena with measurable indicators, the show maintains a link to scientific plausibility, even while embracing speculative elements for narrative effect. The geographic and structural details of Hawkins contribute to the plausibility of interactions with Dimension X. Forests, rivers, and abandoned buildings provide natural conduits and hiding spaces where rifts manifest. The laboratory itself is strategically placed, with underground tunnels, reinforced containment areas, and energy conduits that amplify the potential for dimensional interaction. The town's infrastructure, including power grids, water systems, and transportation networks, inadvertently interacts with these anomalies, creating feedback loops that amplify the perceptible effects of breaches. Characters in Season 5 often note correlations between local disturbances and the formation of temporary portals, suggesting that even mundane features of the town can influence the manifestation of Dimension X. This integration of setting and scientific observation allows the story to anchor its extraordinary elements within a recognizable, measurable environment. In examining the relationship between Hawkins and Dimension X, Season 5 emphasizes the interplay of observation, experimentation, and consequence. The laboratory's activities illustrate that even controlled scientific inquiry can have unpredictable outcomes when engaging with spaces beyond ordinary reality. The town's environment, both natural and constructed, interacts with these outcomes, creating zones of heightened anomaly. Characters navigating these zones must rely on empirical observation, careful documentation, and adaptive strategies to mitigate danger. The narrative presents these efforts as methodical and deliberate, reflecting the principles of real-world scientific investigation while maintaining the tension and wonder that defines Stranger Things. The combination of location, instrumentation, and human observation forms the foundation for understanding how a small town like Hawkins can serve as a focal point for interdimensional phenomena. Finally, Season 5 portrays Hawkins not only as a physical space, but as a conceptual lens through which viewers can engage with complex ideas in an accessible way. Dimension X, with its shifting landscapes and uncertain physics, challenges characters and audience alike to reconsider assumptions about reality, space, and causality. By grounding these fantastical elements in measurable effects, sensory cues, and systematic observation, the show provides a framework for exploring advanced scientific concepts without abandoning narrative clarity. The town, its laboratory, and its residents together form a coherent system through which the extraordinary becomes observable, testable, and narratively meaningful. This approach ensures that while Dimension X may be fictional, the experience of engaging with it resonates with real scientific curiosity, reflection, and caution, establishing the foundation for deeper exploration in subsequent segments of the story. Dimension X, as it emerges in Season 5 of Stranger Things, stretches beyond the familiar boundaries of the Upside Down. It is a place that seems both distant and immediate, existing alongside Hawkins yet separate from it. Its landscapes are jagged and irregular, shifting in ways that defy ordinary observation. Trees or formations appear to grow and collapse within moments, yet the passage of time for the characters is slower, as if the dimension bends both space and temporal flow. The air in Dimension X has a heavy quality, not in a literal sense, but in the way it presses against perception. Colors seem muted, sometimes inverted, with faint, unearthly glows emerging from surfaces. Shadows stretch and retract without connection to visible light sources. There is a constant low hum, like a vibration of energy underlying the fabric of the space. These sensory cues create the impression that Dimension X is alive, or at least responsive to those who enter it. The characters, moving cautiously through this landscape, notice that even small steps can produce disproportionate effects. Rocks shift unexpectedly, surfaces ripple without wind, and faint traces of past activity linger in the environment as echoes. The dimension is not chaotic in the sense of randomness. Rather, it follows rules that are unfamiliar, patterns that hint at an order beyond human comprehension. Scientists and theorists who study the universe in our reality might see analogues to Dimension X in several ways. While the show does not claim scientific accuracy, it draws inspiration from ideas that exist in physics and cosmology. One comparison is to dark matter, a substance thought to compose much of the mass in the universe, yet invisible to instruments that detect ordinary matter. Like Dimension X, dark matter cannot be observed directly with ordinary vision, but its influence is detectable through gravitational effects. In Hawkins, the presence of Dimension X produces measurable disturbances, fluctuations in electromagnetic fields, anomalies in local gravity, and distortions in molecular cohesion of ordinary materials. These manifestations echo how scientists infer the existence of dark matter, not by seeing it directly, but by observing its impact on the world around it. Similarly, the energy that seems to pulse through Dimension X might be likened to vacuum energy, the theoretical background energy present in empty space. This energy is subtle, pervasive, and capable of producing forces that appear out of place within conventional physical frameworks. While these comparisons are not literal, they provide a lens through which the dimension's properties can be contemplated in ways that mirror scientific inquiry. String theory, another scientific framework, offers a different perspective on the concept of multiple dimensions. The theory suggests that the universe may include additional spatial dimensions beyond the three we perceive, folded in ways that are imperceptible at ordinary scales. Dimension X can be imagined as an exaggerated representation of such a hidden dimension, one that is accessible under certain conditions, yet fundamentally different in its structure and rules. In the show, characters encounter areas where walls, floors, or the air itself appears to thin or fold, revealing glimpses of distant spaces or alternative pathways. This visual representation aligns loosely with the idea that higher dimensions could alter the experience of distance and connectivity, creating shortcuts or folds in space that are invisible in everyday life. While string theory remains highly theoretical and its higher dimensions have not been directly observed, the portrayal of Dimension X in Hawkins resonates with the imaginative extrapolation of these concepts. The Hawkins National Laboratory has long been the center for experiments that brush against the unknown. In Season 5, its role is magnified as the lab pushes further into investigations that could pierce the boundaries of ordinary space. Equipment is shown designed to detect minute fluctuations in energy, measure distortions in local fields, and attempt controlled interaction with areas where Dimension X might intersect with the physical world. Researchers record variations in particle behavior, noting instances where conventional laws of motion and conservation appear altered near rifts. Magnetic fields fluctuate without discernible sources. Temperature sensors report sudden changes, and chemical reactions behave unpredictably. These effects suggest that the laboratory's interventions are not merely probing an existing space, but are actively interacting with it, nudging open small pathways that connect Hawkins to Dimension X. The narrative frames this scientific effort as both methodical and experimental, emphasizing observation, repeated measurement, and careful manipulation, even in the face of phenomena that defy ordinary understanding. The dimension itself seems to respond to disturbances. Objects or beings introduced into Dimension X influence the environment around them. This feedback loop creates a dynamic system in which actions have amplified consequences, unlike the predictable results expected in ordinary space. Characters in Season 5 note that even minor disruptions, a footstep, a dropped object, or a surge of psychic energy can trigger shifts in the landscape. This responsiveness mirrors theoretical ideas in physics, where energy and matter interact with the underlying structure of space-time, suggesting that Dimension X operates under principles analogous to high-energy physics. The lab's goal is to quantify these interactions, to map how matter and energy behave in this unusual context, and to understand the limits and thresholds that define the dimension's accessibility. Instruments measure spatial distortions, temporal irregularities, and energetic anomalies, providing a record that demonstrates consistency amid apparent chaos. The physical appearance of Dimension X also conveys its underlying principles. Surfaces that should be solid sometimes yield, as if composed of a different state of matter. Light bends unpredictably, refracting around edges and forming illusions of depth and continuity. The dimension exhibits characteristics akin to a high-energy field, where particles move differently, and matter may enter transient states before settling or returning to normal. In this sense, Dimension X is not merely an alternate space, but a complex system with its own rules, a self-contained environment that nevertheless interacts with Hawkins through rifts and portals. By observing these properties, the laboratory staff in the show attempt to model the dimension, creating simulations and experiments that test the limits of material and energetic interaction. The process emphasizes careful measurement, controlled introduction of variables, and the collection of data to support understanding, reflecting the real-world scientific method. Dimension X's influence extends beyond its immediate borders. In Hawkins, subtle environmental changes indicate the proximity of the dimension. Electrical disturbances, faint vibrations, and temperature anomalies all serve as indicators. Flora and fauna, or their upside-down counterparts, may appear along the edges of rifts, hinting at the dimension's permeability. Laboratory experiments focus on capturing these indicators, using arrays of sensors and monitoring devices to detect patterns that might predict openings or closings of portals. Season 5 portrays these moments as a blend of careful calculation and observation, with the lab staff interpreting each anomaly as a data point. The accumulation of these data points forms a map of interaction, revealing how the dimension's presence manifests in tangible ways, even if the space itself remains largely unseen. The characters' experiences within Dimension X provide additional insight into its nature. 11. With her psychic sensitivity, perceives energy flows and spatial anomalies that others cannot detect. Her interaction with the dimension demonstrates that awareness and perception are critical in navigating the space safely. For others, sensory cues like sound and temperature serve as indicators, allowing them to anticipate shifts or changes. The show emphasizes that Dimension X is not chaotic in an absolute sense. It is ordered, but in a system that differs fundamentally from Hawkins. Understanding these rules, even in part, allows the characters to interact with the space more effectively, highlighting the intersection of human perception, scientific observation, and environmental response. Season 5 demonstrates that navigating Dimension X requires both empirical understanding and intuitive adaptation. Laboratory experiments in the season often involve controlled interaction with objects or individuals capable of influencing Dimension X. Energy pulses, psychic emissions, and environmental manipulations are introduced in measured doses to test the dimension's responsiveness. The lab documents these interactions meticulously, noting the thresholds at which energy or matter passes from one reality to another. These experiments reveal that Dimension X is not a passive environment. It reacts to the presence of matter, energy, and consciousness. The data collected informs the lab's understanding of how portals form, stabilize, and collapse. Through repeated trials, researchers establish patterns that suggest Dimension X obeys consistent rules, even if those rules are unlike the familiar physics of Hawkins. The narrative frames this exploration as careful, systematic, and driven by curiosity, emphasizing a methodical approach despite the high stakes and inherent dangers. In sum, Dimension X in Stranger Things, Season 5 is portrayed as a complex, responsive, and measurable environment. It is distinct from the Upside Down with its own structure, temporal flow, and energy patterns. Scientific analogues such as dark matter, vacuum, energy, and higher dimensional frameworks offer a lens for understanding its properties. The Hawkins National Laboratory functions as the interface between the known and the unknown, employing controlled experiments, precise measurement, and observation to explore and map the dimension. The depiction emphasizes that while the dimension is fictional, it is grounded in a conceptual framework that mirrors scientific curiosity and methodology. This foundation establishes Dimension X, not merely as a narrative device, but as a space that invites examination, reflection, and careful investigation, setting the stage for further exploration of portals and wormhole-like phenomena in the following segments. In the study of the universe, scientists have long contemplated the structure of space and time. The framework that guides modern understanding is general relativity, a theory proposed by Albert Einstein. Within this framework, the geometry of space and time is flexible, capable of bending under the influence of mass and energy. One of the most fascinating predictions of this theory is the concept of a wormhole, also called an Einstein-Rosen bridge. A wormhole is imagined as a tunnel connecting two distant points in space-time, a shortcut that allows travel between locations that would otherwise be separated by vast distances. Unlike ordinary travel through space, a wormhole could, in theory, bring two points together in a manner that defies conventional intuition. The path through the tunnel is not visible from the outside, and its existence would alter the relationships of distance and time in ways that challenge everyday experience. Wormholes are a natural extension of the idea that space-time is not rigid, but a malleable fabric that can be stretched, folded, or linked under certain conditions. The structure of a wormhole requires extreme conditions to exist, conditions that make them more than a curiosity and far from practical reality. In theoretical physics, maintaining a stable wormhole demands exotic matter, a type of matter with properties unlike ordinary matter. Exotic matter would have negative energy density, capable of counteracting the natural tendency of a wormhole to collapse under gravitational forces. Without such a stabilizing presence, the tunnel would pinch off almost immediately, leaving no passage through the connection. Energy requirements for a traversable wormhole are immense, beyond anything humanity can produce with current technology. Even minute fluctuations could destabilize the structure, closing the tunnel and preventing passage. Scientists have also noted that wormholes could potentially create paradoxes if travel allows movement backward or forward in time. These ideas remain speculative, yet they form the foundation for understanding how spaces beyond normal perception might be theoretically linked. Stranger Things, in Season 5, draws on these concepts to frame the portals between Hawkins and Dimension X. The rifts that appear in the town can be compared to miniature wormholes, temporary bridges connecting the familiar reality with a distant, altered space. These portals exhibit qualities reminiscent of theoretical wormholes. They provide a shortcut through space, appear and disappear unpredictably, and react to external forces. While the show does not attempt to depict the mathematical rigor of general relativity, it captures the essence of the phenomenon. A connection between separate realities with consequences that ripple through the surrounding environment. Objects, energy, and even consciousness can pass through these rifts, much like the theoretical passage through a wormhole. The connection is fragile, and interactions often destabilize the portal, demonstrating a visual and narrative parallel to the energy constraints that theoretical physicists describe. In Hawkins, the laboratory's experiments aim to measure, observe, and, in some cases, manipulate these wormhole-like rifts. The instruments detect fluctuations in gravitational fields, small distortions in local space, and anomalies in energy readings that suggest a temporary weakening of the barrier between dimensions. Researchers introduce controlled variables, such as electromagnetic pulses or psychic energy, to see how the rifts respond. These manipulations often result in a chain reaction of measurable effects: flickering lights, shifts in air pressure, and sudden changes in temperature. By observing these outcomes, the lab staff can infer properties of the rifts, such as stability, size, and duration. This method mirrors the scientific approach to wormholes. While the bridges themselves cannot be fully stabilized, their influence on the surrounding environment provides critical data for understanding their properties. The experiments show that even temporary unstable passages have observable and consistent effects. The physical appearance of the rifts in Season 5 provides clues about their underlying mechanics. Edges shimmer or blur, suggesting that space itself is being stretched or warped at the boundary. Objects passing through may distort, elongate, or fragment briefly before reappearing intact, implying that the tunnel through Dimension X has its own rules for matter and energy. In some cases, the rifts appear to resonate with environmental factors, such as electromagnetic fields or nearby energy sources. This sensitivity parallels the theoretical dependence of wormholes on energy distribution and mass. Just as a real wormhole could collapse if the surrounding energy shifts, the rifts in Hawkins respond dynamically to external conditions. The show emphasizes that these passages are not static. They are living, responsive, and fragile, requiring careful attention to prevent collapse or catastrophic consequences. Traversing these wormhole-like rifts presents unique challenges for the characters. 11, with her psychic abilities, can perceive the flow of energy and anticipate openings that others might miss. Others rely on visual, auditory, or tactile cues to detect the presence of a portal. The experience of moving through a rift is disorienting. Distance is compressed, time may feel elongated, and surroundings shift unpredictably. These sensations mirror the theoretical implications of wormhole travel, where conventional understandings of space and time break down. The portrayal emphasizes the difficulty of navigating an unstable connection between realities, reflecting the delicate balance required to maintain a bridge between separate points in space-time. The narrative demonstrates that even small miscalculations can have significant consequences, reinforcing the connection to real-world physics concepts. Energy flow within the rifts mirrors theoretical expectations of wormhole dynamics. The passages in Season 5 exhibit patterns of intense energy concentration at the edges, suggesting a requirement for force or stabilization to maintain the opening. Researchers in Hawkins monitor these energies, noting peaks and fluctuations that correspond with portal activity. These measurements provide insight into the relationship between energy input and spatial deformation. While the show does not quantify these forces numerically, the representation conveys that a consistent input of energy is necessary to create and sustain a passage, echoing the principle that exotic matter or negative energy is required for theoretical wormholes. The connection between energy and structure is a recurring theme, highlighting the interplay between force and spatial integrity. The lab's interventions also reveal the sensitivity of the rifts to environmental context. Certain areas of Hawkins, such as the woods or abandoned buildings, amplify portal activity, while others suppress it. This spatial dependency suggests that the medium through which a wormhole-like passage forms is critical to its stability. In theoretical physics, the fabric of space-time itself is the medium. Any variations in mass, energy, or geometry can influence the potential for wormhole formation. Season 5 adapts this idea, showing that the physical and energetic characteristics of Hawkins play a role in whether rifts appear, how long they persist, and how stable they remain. By mapping these interactions, the lab staff develop a deeper understanding of the spatial and energetic requirements for interdimensional passage. Theoretical discussions of wormholes also address the limits imposed by causality and relativity. In physics, a wormhole could theoretically allow travel backward or forward in time, introducing paradoxes and challenges to conventional understanding of cause and effect. In Stranger Things, Season 5 simplifies this complexity, focusing instead on spatial shortcuts and the immediate consequences of crossing dimensions. Nevertheless, the underlying principle remains. Passing through a rift involves interaction with a space that does not conform to ordinary expectations. Time, distance, and sequence are all subject to alteration, creating narrative tension and reinforcing the scientific inspiration behind the concept. The show captures the essence of these constraints, demonstrating that even temporary or localized bridges between realities carry profound implications. Dimension X itself behaves in ways that echo the predictions of general relativity. The landscape bends, shifts, and responds to the presence of matter and energy, suggesting a dynamic interaction between the two spaces. Rifts form at points of stress or concentration, implying that the structure of the dimension is sensitive to perturbation. Observing these interactions, the lab staff can make inferences about the rules governing the dimension, much as physicists theorize about the geometry of wormholes without direct observation. The feedback between action and environment reinforces the sense that Dimension X is a self-contained yet interconnected space governed by principles that have analogues in real physics, even if simplified for narrative clarity. In comparing scientific wormholes with the rifts of Season 5, several key similarities emerge. Both involve connections between distant points, both require energy to exist, and both are sensitive to disturbances that may destabilize the passage. The differences lie in scale, stability, and the capacity for observation. While real wormholes remain purely theoretical and likely require energies far beyond human capability, the portals in Hawkins are localized, observable, and influenced by measurable variables. This adaptation allows the show to explore complex ideas in a way that is engaging, understandable, and consistent with its narrative logic. It also reinforces the broader theme that human curiosity and intervention can bring extraordinary phenomena within the reach of observation, even if only temporarily. Finally, the portrayal of wormhole-like phenomena in Season 5 emphasizes the interconnectedness of space, energy, and perception. Characters navigating these passages must respond to both measurable indicators and subtle, intuitive cues. The dimension itself reacts to presence, creating a dynamic system that challenges conventional expectations. Laboratory experiments provide data that inform understanding and guide action, demonstrating that even in a fictional setting, the principles of scientific investigation, observation, measurement, and analysis remain central. By grounding the extraordinary in these principles, the show provides a plausible bridge between imagination and scientific inspiration, setting the stage for further exploration of portals, environmental effects, and the consequences of interdimensional interaction in subsequent segments. In Season 5 of Stranger Things, the portals between Hawkins and Dimension X are no longer hidden anomalies. They are active zones of tension and exploration. Characters encounter these openings in moments that range from subtle to dramatic. A shimmer along the floor, a distortion in the air, or an unusual hum alerts them to a nearby rift. At times, the portals are small, appearing as thin fractures or wavering lines along walls, floors, or ceilings. Other times, they expand into larger openings, revealing a glimpse of Dimension X's jagged landscapes, where twisted shapes float and energy pulses in ways unfamiliar to the human eye. Each portal behaves differently, influenced by the environment, the presence of individuals, and the history of prior disturbances in the area. The show emphasizes that the portals are not static. They emerge, grow, shrink, and sometimes vanish entirely, reflecting an unstable equilibrium between dimensions. The characters' first encounters with these rifts highlight the sensory cues that accompany them. 11 often senses a tension in the air, a subtle pull toward the opening, or a psychic echo of motion and energy beyond the portal. Others notice flickering lights, sudden temperature changes, or distorted sound waves that do not correspond to any known source. These indicators allow the characters to approach cautiously, testing the boundary before crossing. The portrayal of these openings conveys a sense of fragility and unpredictability. Even minor disturbances, such as a loud sound, a touch, or a surge of emotional energy, can influence the portal's behavior. The narrative shows that successful navigation requires awareness, patience, and a methodical approach, emphasizing the delicate balance that exists between Hawkins and Dimension X. From a scientific perspective, the portals in Season 5 resemble the conceptual properties of wormholes, but with notable differences. In physics, a wormhole is a theoretical construct that connects two distant points in space-time. Its stability depends on factors such as exotic matter, energy input, and the curvature of space. In Hawkins, the portals are temporary, localized disruptions that form where energy concentrations or environmental stress create weak points between dimensions. They do not require exotic matter in the narrative, yet they behave as if energy and matter must be carefully balanced to maintain an opening. Laboratory readings show fluctuations in electromagnetic fields, gravitational anomalies, and localized distortions in air pressure around the rifts. These measurements suggest that the portals are not mere holes, but zones of altered physics, where the familiar rules are bent and stretched, echoing the conditions necessary for theoretical wormholes while remaining distinct in scale and effect. Energy is a key factor in the formation and maintenance of these portals. In Season 5, the laboratory experiments indicate that energy concentrations, whether natural or induced, correlate with the emergence of rifts, areas with high levels of electrical activity, residual psychic energy, or stress in the surrounding environment tend to generate portals more frequently. Once formed, the openings require a continuous flow of energy to remain stable. If energy input diminishes or becomes irregular, the portal begins to shrink, fluctuate, and eventually collapse. Characters crossing the rifts must move quickly and efficiently, as the duration of stability is unpredictable. The show visualizes this energy through flickering lights, shimmering surfaces, and pulsing distortions, providing tangible cues to the viewer about the portal's life cycle. This representation aligns with the scientific principle that any bridge between separate realities, whether theoretical or fictional, depends on sustained energetic conditions. The size of the portals varies depending on the local environment and the nature of the disturbance. In some cases, rifts appear as narrow slits, large enough for a single hand or object to pass through. In other cases, they expand into arches or gaping holes, revealing the deeper landscapes of Dimension X. The variation in size conveys that the portals are not uniform. They are responsive to both natural and artificial influences. Laboratory instruments measure the dimensions of openings over time, noting expansion and contraction patterns. Observations indicate that spatial distortions extend beyond the immediate boundary, subtly warping the surroundings and creating gradients of altered physics. These gradients affect both matter and energy, influencing movement, light, and even sound near the portal. The show's depiction demonstrates that size is not simply a static measure, but a dynamic property intertwined with stability and energy distribution. Stability, perhaps the most critical characteristic of these portals, is influenced by multiple factors. Emotional energy, psychic input, and environmental stress all contribute to the rift's persistence. For example, when 11 exerts control through her abilities, a portal may hold longer, allowing safe passage. Conversely, chaotic events, loud disturbances, or improper alignment of experimental equipment can destabilize a rift, causing it to collapse suddenly. Laboratory sensors track fluctuations in magnetic fields, gravitational readings, and energy spikes, providing a record of how the portal responds to various stimuli. These data suggest that even minor disruptions have amplified effects, reinforcing the fragility of the connection. The narrative conveys this precariousness consistently, ensuring that characters' movements are cautious, deliberate, and guided by observation. Portals also influence the surrounding environment in measurable ways. Air pressure, temperature, and electromagnetic fields change near openings. Plants and small animals, or their equivalents from Dimension X, may appear close to rifts, indicating a partial permeability of the boundary. These environmental shifts act as indicators for the characters, signaling where a portal might be present, even if it is not immediately visible. The laboratory tracks these indicators, cross-referencing them with known disturbances to predict portal activity. This methodical approach mirrors scientific study in the real world, emphasizing observation, data collection, and inference. By interpreting these environmental signals, characters gain an advantage in navigating the unstable zones between dimensions. The mechanics of passage through the portals are depicted in a manner that highlights the contrast between human perception and the underlying physics. When an object or person enters a rift, it may appear to stretch, blur, or shimmer before fully crossing into Dimension X. The space within the portal is not empty. It is filled with an energy field that interacts with matter in ways that defy conventional expectation. While the show does not depict the precise calculations required to maintain such a field, it conveys the principle that transition between realities requires careful handling of energy and matter. The crossing process emphasizes that the portals are not merely openings, but active interfaces, shaped by the flow of energy and the conditions of the environment. Interactions with the portals reveal patterns that suggest predictability within chaos. Rifts often appear in areas of repeated stress, such as near laboratory equipment, natural fault lines in the town's underground structures, or regions of high psychic activity. By mapping these occurrences, the lab can forecast likely portal locations and anticipate periods of instability. This approach reflects scientific methodology, identifying patterns, forming hypotheses and testing predictions. While the dimension remains largely unpredictable, these patterns offer the characters a framework for understanding and navigating the openings, illustrating the balance between uncertainty and observation that defines the investigation of extraordinary phenomena. Dimension X itself reacts to the presence of portals. The internal structure of the dimension is dynamic, responding to breaches by shifting landscapes, amplifying energy flow, or altering matter near the boundary. These reactions create feedback loops that affect portal stability, making crossings more complex. Characters must consider both the local conditions in Hawkins and the response of Dimension X to safely interact with the rifts. Laboratory observations of these feedback mechanisms highlight the interplay of energy, matter, and environmental context, reinforcing the principle that the portals are not static conduits but responsive systems. Each interaction teaches the characters more about the nature of interdimensional connection, shaping their strategies for safe traversal and study. Finally, the depiction of portals in Season 5 emphasizes the interplay of physics and narrative necessity. While current science does not provide a mechanism for temporary, self-stabilizing interdimensional openings, the show translates theoretical principles into observable phenomena. Energy flow, size variation, environmental interaction, and stability constraints are all represented in ways that are understandable and visually coherent. The result is a compelling, scientifically inspired portrayal of a fictional bridge between worlds, where characters must rely on observation, measurement, and intuition to navigate the unpredictable zones between Hawkins and Dimension X. These portals serve as both plot devices and conceptual illustrations, grounding extraordinary events in a framework that resonates with scientific curiosity and methodical investigation. The Hawkins National Laboratory has long been the focal point for the unusual events in the town, and in Season 5, its role grows ever more central. The lab, hidden beneath layers of security and bureaucracy, continues to pursue experiments that blur the boundary between the human mind and the unknown dimensions. Among its subjects, 11 stands as the most studied and capable of interfacing with areas beyond ordinary perception. From the earliest seasons, her abilities have been monitored, measured, and amplified through rigorous testing. In this season, her interactions are more complex, involving not just observation or telekinesis, but the active probing of Dimension X itself. The laboratory establishes controlled environments where her psychic powers are directed to detect energy flows, locate rifts, and even manipulate the portals to some degree. Each session is recorded, documented, and cross-referenced with the equipment readings to map the effect of her actions on both the environment and the dimension beyond. Other subjects in the lab serve as additional points of comparison and study. Some possess latent psychic abilities, while others are part of control groups or undergo monitoring to assess human response to extreme conditions. Experiments focus not only on the manifestation of psychic energy, but also on its measurable effects on matter, electromagnetic fields, and localized spatial distortions. The lab employs a wide array of technology: sensors that measure magnetic fluctuations, arrays that detect subtle gravitational shifts, and devices that record electromagnetic emissions. High-speed cameras capture changes in light, motion, and physical distortion near test subjects. Data streams are meticulously analyzed to determine correlations between psychic output, environmental reaction, and rift formation. Each observation adds to a growing body of knowledge, illustrating that even human consciousness, under certain conditions, can influence spaces beyond ordinary perception. The scientific parallels drawn by these experiments are compelling. Neuroscience recognizes that the brain generates complex electrical and chemical signals which govern perception, action, and cognition. The lab explores whether these signals, amplified and focused through controlled procedures, can extend influence beyond the immediate environment. In speculative quantum consciousness models, some theorists propose that consciousness could interact with quantum fields, influencing outcomes at the smallest scales. While these theories remain debated and largely unproven, the show adapts them to its narrative, suggesting that psychic energy may resonate with the structures of Dimension X, creating observable changes and even enabling the temporary formation of portals. Eleven's experiences illustrate a continuity between mental focus and physical manifestation, where thought, concentration, and emotional intensity shape the interaction with other dimensions. Laboratory equipment is designed to enhance, measure, and contain these interactions. Subjects are placed in sensory-controlled rooms, where variables such as light, sound, and electromagnetic interference can be managed. Fields of energy are generated through electrodes, conductive surfaces, and magnetic arrays designed to channel psychic activity. High-precision instruments monitor subtle shifts in gravity, temporal anomalies, and fluctuations in particle behavior. When 11 focuses on a target area in Hawkins or attempts to interact with a rift, these instruments capture data that can indicate the intensity of her influence, the response of the environment, and the potential for opening or stabilizing a portal. Observers interpret the readings to refine procedures, adjust parameters, and understand the limits of human influence on interdimensional spaces. Experiments often reveal unexpected consequences. Even carefully controlled sessions produce side effects in the surrounding environment. Electrical systems in the lab may fluctuate, minor structural tremors occur, and temperature variations manifest unpredictably. These reactions suggest that psychic energy, when focused or amplified, has tangible, measurable effects on the material world. The narrative of Season 5 emphasizes that these disturbances are not random, but correspond to patterns of energy release, concentration, and interaction with localized space. By cataloging these effects, the laboratory can correlate mental focus with environmental impact, highlighting the link between human activity and the physical manifestations of rifts in Dimension X. The implications are significant, as they suggest a bridge between human consciousness and the rules governing alternate dimensions. The human element is central to understanding these phenomena. Subjects in the lab experience a range of physical and psychological effects during experiments. 11, for instance, endures fatigue, disorientation, and intense sensory input, all of which are magnified when she engages with portals or attempts to influence the dimension. Others experience stress responses, heightened perception, or unexplained sensations in areas where rifts form. The show portrays these effects with attention to realism. Physical strain, emotional tension, and cognitive load are all consequences of interfacing with an environment that is both alien and responsive. These human reactions serve as markers for scientists, indicating the intensity and scope of interdimensional influence and providing additional layers of data for analysis. The formation of interdimensional rifts is linked closely to the laboratory's technological interventions. Equipment designed to measure and manipulate energy fields often creates conditions conducive to portal formation. For example, magnetic arrays, when pulsed at specific frequencies, can interact with psychic emissions to weaken the barrier between Hawkins and Dimension X. Controlled bursts of energy create temporary alignments in the fabric of space, allowing openings to appear. These processes suggest that rifts are not purely spontaneous. They can be induced or stabilized through careful combination of human focus and technological input. The narrative demonstrates that laboratory intervention is a double-edged sword. While it allows for controlled study, it also introduces the risk of unintended consequences, as poorly timed or misaligned energy can amplify disturbances or destabilize existing portals. Monitoring systems in the lab provide insight into the mechanics of these interactions. Instruments track energy flow, spatial distortion, and environmental variables with high temporal resolution. Data logs capture every fluctuation in electromagnetic activity, gravitational anomalies, and psychic resonance. This allows researchers to identify thresholds at which rifts appear or collapse. Repeated experiments build a predictive model, linking psychic intensity, equipment output, and environmental factors to the likelihood of interdimensional openings. These models, while simplified for narrative clarity, reflect the principles of empirical study: observation, measurement, hypothesis, and iterative testing. The characters' experiences, combined with the technological data, create a feedback loop of understanding, gradually revealing the structure and behavior of Dimension X through direct and indirect observation. Experiments also explore the interaction between multiple subjects and collective psychic activity. When more than one individual engages with a rift simultaneously, the effects are amplified, sometimes stabilizing openings or enlarging them temporarily. Conversely, conflicting or poorly coordinated focus can destabilize a portal, causing it to fluctuate or collapse. This highlights the sensitivity of interdimensional connections to both human input and environmental factors. The lab's experiments test these interactions systematically, documenting how variations in intensity, coordination, and energy alignment influence the behavior of the rifts. Such findings underscore the principle that human consciousness, when concentrated and measured, can produce observable changes in the environment, particularly in spaces where the boundary between dimensions is thin. The laboratory also examines long-term consequences of exposure to interdimensional phenomena. Subjects show cognitive and emotional shifts after repeated sessions, including heightened perception, residual sensory impressions from Dimension X, and physiological stress responses. Researchers monitor these effects, seeking correlations between duration, intensity, and type of interaction. The observations suggest that sustained contact with unstable dimensions can have cumulative effects on human subjects, reinforcing the importance of controlled experimentation. The show portrays these long-term consequences with subtlety, demonstrating that engagement with Dimension X leaves measurable traces on both mind and body, even when no immediate danger is apparent. This emphasis on cause and effect aligns with scientific principles, linking observation to outcome. Finally, the laboratory's work demonstrates a clear link between technology, human consciousness, and the creation of interdimensional rifts. Psychic energy, when guided and amplified through specialized equipment, can produce measurable effects on the boundary between Hawkins and Dimension X. Observations of environmental disruption, sensory feedback, and portal formation all point to a system in which human focus and technological intervention interact to shape the structure of space. The narrative emphasizes that these interactions are not magical, but subject to patterns, limits, and reproducible outcomes. By portraying the laboratory as a space of careful measurement, experimentation, and reflection, Season 5 presents the human role in interdimensional phenomena as both active and measurable, grounding the extraordinary events in a framework inspired by real scientific methodology. The lab is not just a place of study. It is the interface where human cognition, technology, and alternate dimensions converge, creating the conditions under which portals, rifts, and other phenomena can be observed and understood. In Stranger Things, Season 5, the breaches between Hawkins and Dimension X are no longer confined to hidden corners or laboratory corridors. Their presence reaches into the town itself, subtly altering the environment and leaving traces of another reality in the ordinary world. Flora near the rifts shows unusual growth patterns, twisted and distorted as if responding to unseen forces. Leaves may shimmer with colors that defy natural explanation, or veins may appear to pulse faintly with energy. Trees near portals sometimes lean or bend in directions unrelated to wind or gravity, their roots shifting in response to disturbances in the underlying fabric of space. These changes occur gradually, accumulating over hours or days, creating zones where the ordinary landscape feels uneasy, familiar, yet alien. Small animals and insects exhibit altered behavior as well. Birds circle rift zones hesitantly, avoiding certain areas, while rodents scurry in unusual patterns. In some cases, creatures appear affected physically, as if the energy of Dimension X interacts with their biological systems, changing their movement or appearance in ways that are startling but consistent within the narrative logic of the show. The atmosphere near interdimensional breaches is altered in measurable ways. Temperature shifts are common, often sudden and localized. A room might be noticeably colder near a portal, or a patch of forest might grow oppressively warm as energy concentrations fluctuate. Humidity and air pressure can change as well, producing small gusts, swirling dust, or the faint vibration of air molecules. Lights flicker in electrical systems, and devices sensitive to electromagnetic fluctuations respond unpredictably. These environmental impacts serve as indicators for the characters, warning them of nearby rifts, even when visual cues are absent. The narrative emphasizes that the breaches are dynamic, their effects cascading outward in subtle yet perceptible ways. Just as laboratory readings track fluctuations in energy and matter, these environmental changes demonstrate that the reach of Dimension X extends beyond its immediate boundaries, affecting the surrounding world in ways both visible and measurable. In real-world terms, these alterations can be compared to phenomena such as chemical contamination or ecological shifts. Pollutants entering an ecosystem can cause plants to mutate, disrupt animal behavior, and modify environmental conditions. Similarly, when energy from Dimension X interacts with Hawkins, it introduces an unfamiliar influence that produces systemic changes. While fictional, these parallels offer insight into how the writers use environmental science as a grounding principle. High-energy interactions, whether in physics or speculative narrative, have cascading effects on matter and energy, altering systems in complex and often unexpected ways. The depiction of flora and fauna responding to rift activity mirrors the real-world principle that even subtle external forces can shift ecological balance, causing observable effects over time. Energy transfer between dimensions plays a critical role in these environmental impacts. The rifts act as conduits, allowing energy from Dimension X to flow into Hawkins. This energy is not uniform. It fluctuates in intensity and frequency, creating zones of high activity and low activity. In some cases, energy pulses are visible as shimmering distortions or faint glows along surfaces. In other cases, the energy manifests as subtle perturbations, affecting air movement, pressure, or electromagnetic fields. This interaction illustrates a principle that is familiar in high-energy physics. The movement of energy across boundaries can produce changes in matter, induce motion, and alter the behavior of systems. The show represents these interactions visually, providing cues for the audience and the characters, while maintaining internal consistency within its depiction of interdimensional physics. Matter itself is affected near the breaches. Small objects may levitate or shift in response to fluctuating energy fields. Liquids ripple or change density temporarily, and surfaces may appear to shimmer or warp. These phenomena suggest that energy from Dimension X interacts directly with matter, producing effects akin to conversion or manipulation at a fundamental level. While the show does not delve into the precise mechanics, the visual and narrative cues are consistent with the principle that energy can influence material structure. In high-energy physics, matter and energy are interchangeable under certain conditions, and the rifts in Hawkins serve as a dramatic, accessible representation of this principle. Characters observing these effects gain critical information about the rift's intensity, stability, and potential hazards, guiding their actions and decision-making. Environmental feedback loops are common around persistent breaches. Energy, flowing from Dimension X, interacts with matter and the local environment, which in turn affects the stability of the rift. For example, a tree absorbing energy through its roots may slightly alter the distribution of energy around a portal, causing fluctuations in portal size or duration. Nearby animals, sensing or responding to energy changes, can inadvertently influence the environment further, amplifying or damping the rift's activity. These loops create a complex system in which cause and effect are intertwined, demonstrating that interdimensional interaction is dynamic rather than static. The lab monitors these feedback mechanisms, using sensors to track how energy propagates through the environment and how local variables, temperature, motion, electromagnetic fields, correlate with rift behavior. Hawkins' water systems and soil also exhibit measurable effects near breaches. Puddles or streams can develop unusual surface tension, refracting light in strange ways or showing faint, shimmering patterns. Soil may show altered conductivity, responding to the fluctuating energy from Dimension X. Plant growth is influenced not only in direction and form, but also in cellular activity, with leaves and roots displaying abnormal patterns under microscopic observation. These depictions reinforce the idea that energy transfer has practical consequences on matter and the biosphere. Characters navigating these zones must account for both the visible and invisible effects, understanding that the environment itself is an active participant in the interdimensional dynamic. Season 5 also illustrates the scale of these environmental impacts. Localized breaches can create zones several meters wide with noticeable changes in flora, fauna, and atmospheric conditions. Larger or prolonged rifts have more extensive influence, causing shifts in microclimates, altered animal migration patterns, and even disruptions in human activities. The show emphasizes that the extent of the impact correlates with the intensity and duration of energy flow, aligning with the scientific principle that higher energy levels produce larger effects on matter and systems. By observing patterns over time, both characters and lab personnel develop predictive models for environmental response, allowing them to anticipate hazardous zones or areas likely to experience amplified rift activity. Human perception of these environmental changes provides additional data. Characters note subtle differences in air quality, temperature, and light, which often precede visible phenomena. 11 can sense energy concentrations before a rift forms, and others detect minute alterations in sound, vibration, or motion. These human indicators complement laboratory instruments, creating a multi-layered system of observation. The interplay between perception and measurable effects demonstrates a narrative reflection of the scientific principle that observation is an integral part of understanding a system, particularly one as complex and responsive as an interdimensional breach. Energy accumulation near the rifts sometimes results in temporary manifestations of Dimension X's matter or energy. Small objects may flicker between realities, partially materializing before returning to Hawkins. Faint outlines of alien shapes appear near breaches, interacting briefly with the environment. These occurrences illustrate how energy transfer can produce tangible effects on matter, consistent with speculative high-energy physics, where sufficient energy density can alter or convert matter temporarily. While fictionalized, these visualizations maintain internal logic, showing that breaches are active, responsive zones where energy, matter, and space interact continuously. Environmental monitoring remains a key tool for both characters and laboratory staff. Sensors, cameras, and recording devices track temperature, electromagnetic activity, pressure, and movement in areas affected by rifts. Data from these sources informs strategies for containment, traversal, and study. Patterns emerge, showing that environmental shifts often precede or predict portal behavior, creating opportunities to prepare for or mitigate unexpected consequences. These observations underscore the principle that even extraordinary phenomena can be studied systematically, with repeatable measurements and analysis guiding understanding. Finally, the depiction of environmental impact in Season 5 underscores the interconnectedness of all systems around interdimensional breaches. Flora, fauna, air, water, and human observers all respond to the flow of energy from Dimension X, creating a network of interactions that influence the stability and character of portals. The show visualizes these dynamics in a way that is clear and comprehensible while maintaining the impression of complexity. By combining environmental observation, energy monitoring, and human perception, Season 5 presents a cohesive, scientifically inspired portrayal of how breaches affect the world of Hawkins, grounding fantastical events in a framework that parallels real-world principles of energy transfer, matter interaction, and ecological response. In Season 5 of Stranger Things, the experience of Dimension X is as much about human perception as it is about scientific phenomena. The main characters confront the unknown, not only through observation, but through direct interaction with rifts, portals, and energy fields. For Eleven, the dimension is both a tool and a threat. Her psychic abilities allow her to sense the flow of energy, the positions of rifts, and the behavior of objects in ways that ordinary senses cannot detect. These abilities, however, come at a cost. Every engagement with Dimension X produces physical and mental strain. Her perception stretches beyond the usual limits of human cognition, encountering environments where time and space behave unpredictably. The lab records these sessions meticulously, noting pulse rate, neural activity, and the subjective reports she provides. Her experiences illustrate the challenge of navigating a reality that does not adhere to familiar rules, highlighting the intersection of perception, adaptation, and cognitive load. Other characters, such as Mike, Dustin, and Lucas, experience Dimension X differently. Without psychic abilities, they rely primarily on sensory cues and environmental feedback. The shimmer of a portal, the vibration of the air, and subtle shifts in temperature guide their understanding of the breaches. Fear is a constant companion. The unknown properties of the rifts create tension, and the unpredictability of events challenges their ability to adapt quickly. Their psychological responses align with known principles of human behavior in extreme or novel environments. Stress responses, such as heightened alertness, increased heart rate, and rapid information processing, occur in moments of uncertainty. Observing these reactions, both within the narrative and through laboratory measurements, reveals how human perception adapts under conditions that strain cognitive and sensory limits. Dimension X itself influences perception directly. The visual landscape appears warped, with irregular geometry, shifting lights, and floating objects that defy normal spatial rules. Sounds are distorted, sometimes echoing in unexpected directions or carrying a resonance that cannot be traced to a physical source. These perceptual anomalies challenge the character's sensory processing, forcing them to adapt in real time. Eleven's abilities allow her to compensate, perceiving energy patterns and spatial structure beyond ordinary senses. Others must rely on intuition, teamwork, and external instruments to navigate. The depiction illustrates a scientific principle. Human senses evolved for familiar environments, and extreme or altered conditions reveal the limitations and plasticity of perception. In encountering the unknown, the characters learn to interpret new forms of sensory input, creating mental maps of a reality that resists conventional understanding. Psychological strain is a recurring theme. Continuous exposure to rifts, energy fluctuations, and the alien properties of Dimension X produces fatigue, anxiety, and occasional disorientation. Eleven experiences intense mental exertion as she channels psychic energy, often resulting in headaches, blurred vision, and tremors. Others experience acute stress responses, including hypervigilance, emotional instability, and difficulty maintaining focus. The narrative conveys that the unknown exerts pressure not just on the body, but on the mind, consistent with psychological studies of extreme environments. When human cognition encounters unpredictable, high-intensity stimuli, Neural circuits prioritize survival, attention, and rapid assessment. The character's responses reflect this adaptation, showing heightened awareness in some domains and cognitive strain in others. Exposure to unknown physics has measurable effects on cognition and behavior. Characters report distortions in time perception, as moments can feel elongated or compressed when near rifts. Spatial relationships appear altered. Distances that seem short may feel impossibly long, and straight paths may curve unexpectedly. These effects mirror theoretical discussions in physics and neuroscience about how altered environments influence mental processing. High-energy fields, unpredictable spatial geometry, and dynamic energy flows produce conditions that stress perception and memory, requiring rapid adaptation. Characters develop coping mechanisms, such as focusing on fixed points, relying on auditory cues, or collaborating to map the environment collectively. These strategies reflect adaptive behavior in complex or unstable systems, illustrating that human cognition is flexible but limited when confronted with realities that do not conform to ordinary laws. The emotional impact of interacting with Dimension X is significant. Fear, awe, and uncertainty shape decision-making. Characters often hesitate, weighing the potential danger against necessity. The narrative emphasizes that psychological state directly influences performance. Heightened stress can impair coordination, reduce reaction time, and amplify mistakes, while focused attention improves perception and interaction with portals. Eleven's training in controlling psychic energy parallels real-world cognitive training, where disciplined focus enhances performance under stress. Her experience demonstrates that skill and adaptation can partially compensate for environmental unpredictability, even when the underlying physics is alien. Other characters develop their own techniques, showing that observation, strategy, and careful action are critical for navigating a dimension that challenges human perception at every turn. Perception of time within Dimension X is particularly affected. In some scenes, moments stretch, giving the impression of slow motion. In others, events unfold rapidly, compressing the sequence of cause and effect. Characters respond by recalibrating their internal sense of timing, using external cues such as sound, light, and movement to anticipate changes. Neuroscience suggests that human perception of time is highly malleable, influenced by attention, stress, and novelty. The show dramatizes this principle, showing that the unfamiliar structure of Dimension X interacts with cognitive processing, producing experiences that feel both disorienting and revealing. Observing these interactions allows characters and the audience to understand that even basic perception is contingent on environmental conditions, particularly those that challenge the norms of physics. Spatial disorientation is another common effect. The geometry of Dimension X is irregular, with surfaces that shift or bend unpredictably, and distances that appear inconsistent. Characters must constantly adjust their movement strategies, relying on reference points, careful observation, and intuition. Eleven's psychic insight provides a map of energy flow, allowing her to anticipate changes in space. Others must rely on trial and error, learning to navigate through direct experience. These adaptations reflect the concept of sensory recalibration, where repeated exposure to novel spatial conditions enables improved performance. While the environment remains alien, human cognition exhibits plasticity, gradually developing strategies for safe traversal, threat assessment, and effective interaction with altered reality. Interactions between characters and the dimension highlight the interplay between physical sensation and psychological state. Energy fields produce tactile effects, air pressure shifts, vibrations, and heat or cold fluctuations that characters interpret as information. Emotional state modifies perception, intensifying the impact of fear or amplifying sensitivity to energy cues. The narrative suggests that cognition is not passive but responsive, with sensory input, mental state, and external conditions forming a feedback loop. Laboratory data support this idea. Stress markers, neural readings, and physiological indicators fluctuate in correlation with exposure to rifts. This convergence of observation, experience, and measurement illustrates a scientifically inspired framework for understanding human response to extraordinary environments. Adaptation emerges as a critical theme. Repeated exposure to rifts, energy fluctuations, and the visual and tactile anomalies of Dimension X leads to gradual improvements in perception and decision-making. Characters learn to recognize early warning signs, anticipate spatial distortion, and interpret energy signals. Even in the absence of psychic abilities, experience provides predictive power, allowing them to act more effectively under uncertainty. This adaptation mirrors known principles in neuroscience and psychology. Humans adjust to novel or extreme stimuli, developing coping strategies and enhancing sensory integration. The show portrays this learning process as gradual, cumulative, and dependent on both individual skill and collaborative effort. Finally, Season 5 emphasizes that the human experience within Dimension X is a mixture of wonder, danger, and cognitive challenge. Characters confront unknown physics, altered space, and unpredictable energy flows, all while managing fear, perception limits, and psychological strain. Eleven's psychic abilities offer a unique interface with the dimension, while others rely on observation, inference, and strategy. The narrative conveys that engagement with an alien environment is not solely a matter of courage, but also of adaptation, measurement, and interpretation. Exposure to rifts, portals, and energy fields produces measurable cognitive effects, requiring both mental and physical adjustments. By presenting human experience alongside interdimensional phenomena, the show creates a rich, scientifically inspired depiction of how consciousness interacts with the unknown, blending narrative drama with principles of perception, adaptation, and sensory processing. In Season 5 of Stranger Things, the events surrounding Dimension X and its interaction with Hawkins raise questions that border on the impossible, at least from a scientific standpoint. The show depicts rifts opening, matter crossing boundaries, and energy flows creating temporary bridges between realities. To analyze this, one must start with the theoretical basis for interdimensional travel in physics. Wormholes, or Einstein-Rosen bridges, are the most commonly cited structures that could connect distant points in space-time. In theory, a wormhole forms when space is curved in such a way that two distant regions are connected by a tunnel, potentially allowing matter, energy, or information to pass through. This requires extreme conditions, including immense gravitational forces and, critically, the presence of exotic matter to keep the tunnel from collapsing. Exotic matter is a hypothetical form of matter with negative energy density, something that has not been observed in reality but is essential in equations that describe stable wormholes. In Stranger Things, The rifts in Hawkins behave as if they mimic wormhole dynamics, but without the known requirements. The portals appear spontaneously, sometimes collapsing quickly and other times remaining stable for hours or days. Characters can traverse them without encountering lethal tidal forces or energy fields that would destroy ordinary matter. In physics, such conditions would demand precise control over gravitational curvature, energy density, and spatial topology, factors that are not controlled or even explained within the narrative. The show instead attributes stability to psychic energy, laboratory equipment, and environmental factors, creating a fictional mechanism that aligns with the story rather than known physical laws. Despite this, the sequence of events can be compared to theoretical frameworks to identify where the depiction aligns loosely with science and where it diverges completely. Quantum mechanics offers another lens for understanding the plausibility of Dimension X. Quantum theory describes behavior at very small scales, where probability, wave-particle duality, and superposition dominate. Some speculative theories suggest that consciousness or observation could influence quantum states, a notion explored in science fiction but debated in scientific circles. Eleven's psychic abilities are depicted as an interface that interacts with the underlying structure of Dimension X, enabling her to manipulate the rifts. In real-world terms, there is no evidence that human thought can directly alter quantum systems on macroscopic scales, let alone open interdimensional portals. Nevertheless, the narrative uses this idea to provide an internally consistent mechanism within the fictional universe, showing that human focus and emotional intensity influence portal formation and stability. String theory provides a third framework. In string theory, additional spatial dimensions beyond the familiar three exist, curled tightly at scales far smaller than atoms. The idea of parallel dimensions, or branes interacting in specific configurations, is explored mathematically, suggesting that interactions could, under extreme or controlled conditions, produce localized effects on space-time. The upside down in Stranger Things can be seen as a dramatization of such a concept, a parallel reality connected to our own through rare and unstable interactions. The series visualizes this by showing mirrored landscapes, energy distortions, and altered matter properties. While string theory does not provide a practical method for accessing or traveling through these dimensions, it offers a framework to understand the imaginative leap the show makes from theoretical mathematics to narrative fiction. Step-by-step analysis of portal creation within the story highlights several fictional shortcuts. First, an energy concentration, psychic or technological, forms a local disturbance in space. This disturbance weakens the boundary between Hawkins and Dimension X, producing a temporary opening. Objects, energy, or living beings can pass through if conditions remain stable. The opening requires continuous energy input to maintain itself, and any fluctuation can cause the portal to collapse. While this sequence is internally consistent within the story, it diverges sharply from the constraints of real physics. Real wormholes, even if theoretically possible, would demand precise energy and matter conditions far beyond the reach of human manipulation, with any passage through them subject to destructive gravitational forces. The show simplifies these barriers to focus on character interaction and plot progression. The plausibility of interdimensional travel, even in controlled scenarios, remains extremely limited according to current scientific understanding. Wormholes in relativity require exotic matter to prevent collapse, and the forces involved in maintaining stability would likely disintegrate ordinary objects. Energy scales necessary for such an event are astronomical, far beyond the capacity of laboratory equipment or psychic abilities. Any matter entering an unstable wormhole would encounter extreme tidal forces, likely stretching, compressing, or destroying it. Stranger Things bypasses these constraints by introducing fictional stabilizing factors such as psychic resonance and environmental alignment. These fictional elements serve the narrative but highlight the gap between visual spectacle and scientific feasibility. Despite these divergences, the series incorporates scientifically inspired elements in its depiction. Energy flow, feedback loops, and environmental interaction are consistent with known principles of physics, even if they are simplified. The portrayal of portals responding to environmental variables, air pressure, electromagnetic fields, temperature changes, mirrors real-world systems where energy interacts with matter. Fluctuations in portal size and stability reflect the need for equilibrium in dynamic systems, drawing a loose analogy to concepts in high-energy physics, where energy and matter must balance to maintain structure. These elements provide a sense of realism while still operating within a fictional framework. Comparisons to known physics also reveal gaps in causal explanation. For instance, the formation of portals in Hawkins does not require exotic matter or the extreme gravitational forces demanded by real wormholes. Passage through portals occurs without protective measures against tidal forces or radiation that would be present in a theoretical wormhole. Time and space within Dimension X remain navigable without relativistic distortions. These simplifications are deliberate, allowing the story to focus on character experience rather than physics constraints. They also highlight the difference between theoretical models, highly constrained, mathematically precise, and physically extreme, and narrative constructions, which prioritize continuity, drama, and audience comprehension. The series also explores partial energy and matter conversion. Objects crossing portals may undergo changes in appearance or structure, suggesting interactions at a fundamental level. High-energy physics allows for matter-energy equivalence under extreme conditions, but in reality, manipulating ordinary matter in such a way would require energy levels comparable to stars or particle accelerators far beyond current technology. Stranger Things uses psychic and technological input as a stand-in for these extreme conditions, creating a visual and narrative analog rather than a literal translation of physics. The approach is scientifically inspired, yet intentionally simplified, making the events accessible and believable within the story world without claiming real-world feasibility. In conclusion, the events of Stranger Things Season 5 illustrate both a creative adaptation of scientific ideas and a clear departure from real-world constraints. Wormholes, quantum mechanics, and string theory provide a framework to imagine interdimensional interaction. But the conditions necessary for such phenomena are far more extreme than those depicted. The narrative compensates with psychic energy, laboratory technology, and environmental feedback, creating internally consistent portals that serve plot and character development. While scientifically impossible under current understanding, the portrayal retains a sense of realism by integrating measurable environmental effects, energy dynamics, and patterned interaction with human agents. The series demonstrates how theoretical concepts can be transformed into compelling story elements while acknowledging the limits of actual physics. In Stranger Things, Season 5, the use of interdimensional phenomena is not only a visual spectacle, but also a deliberate narrative tool. The writers chose to depict rifts, portals, and the Upside Down not merely as threats, but as instruments to explore character, tension, and thematic depth. Dimension X, with its alien landscapes and unpredictable physics, functions as a mirror to the town of Hawkins and the internal struggles of its inhabitants. By introducing spaces where ordinary rules of reality are suspended, the narrative creates opportunities for characters to confront fear, test their abilities, and reveal hidden strengths. The scientific concepts that inspire these phenomena, wormholes, energy flow, and altered matter, serve as metaphors for uncertainty, danger, and the complexity of the human mind. The choice to focus on interdimensional physics provides a framework through which psychological, emotional, and moral challenges can be explored with clarity and intensity. Wormholes and rifts in the story carry symbolic weight. They represent the unknown, the instability of reality, and the thin boundary between safety and danger. For the characters, encountering a portal is a moment of decision, forcing them to balance caution with action, curiosity with fear. These narrative devices reflect the scientific principle that interactions with extreme conditions provoke measurable responses, though in the show they are dramatized for effect. By structuring events around the appearance, growth, and collapse of rifts, the writers give physical form to abstract concepts such as risk, consequence, and the unpredictability of life in Hawkins. The Upside Down is simultaneously a literal threat and a metaphorical landscape of anxiety, trauma, and transformation, providing a setting where character development and story progression intersect seamlessly. Science-inspired storytelling enhances immersion and plausibility. The depiction of portals as dynamic structures that respond to energy, human focus, and environmental factors mirrors real-world principles of system feedback and interdependence. Laboratory instrumentation, character observations, and environmental effects all contribute to a sense that the events, while fictional, operate according to an internally consistent logic. This consistency allows audiences to engage with the story in a way that feels grounded. The narrative emphasizes measurable consequences. Objects shift, air vibrates, flora and fauna react, and human cognition adapts. These details, inspired by the principles of physics, ecology, and neuroscience, give the supernatural elements a weight that reinforces tension and stakes within the town of Hawkins. Character arcs are shaped by these scientific and symbolic phenomena. Eleven's psychic abilities evolve in response to the challenges of Dimension X, demonstrating growth in skill, control, and emotional resilience. Other characters develop observational and strategic skills, learning to read subtle cues in the environment, anticipate portal behavior, and coordinate collective action. These arcs are intertwined with the presence of rifts, as the physical manifestations of Dimension X create conditions that test resourcefulness, courage, and cooperation. The writers use the science-inspired elements to construct moments of high drama, but also to highlight incremental development in character competence and understanding. In this way, the fantastical elements serve narrative function, illustrating progress, tension, and adaptation through interaction with a scientifically inspired setting. The symbolic resonance extends to the town itself. Hawkins, usually depicted as a small, ordinary town, becomes a site where extraordinary physical principles intersect with everyday life. The presence of rifts and the influence of Dimension X disrupt normality, creating zones of uncertainty that mirror the emotional and social challenges faced by the characters. Energy flows and environmental disruptions are not only plot devices, but also symbolic indicators of underlying instability. These shifts reinforce themes of vulnerability, resilience, and the permeability of boundaries between realities, between fear and courage, and between knowledge and the unknown. The interplay of physics-based phenomena and human experience creates a layered narrative where metaphor and plot action are inseparable. The tension derived from interdimensional phenomena is both immediate and cumulative. Individual portals may produce localized hazards, requiring careful navigation and problem-solving. Larger or persistent breaches create cascading consequences, affecting entire neighborhoods and testing the character's capacity to respond under pressure. The narrative uses these escalating challenges to maintain suspense, illustrate the stakes of scientific interaction with unknown forces, and explore the moral and emotional implications of action and inaction. By grounding these events in the appearance, energy, and responsiveness of the rifts, the writers ensure that tension is consistent, understandable, and tied directly to the scientific logic of the setting. Visual and sensory representation also contributes to the narrative function. The Upside Down is depicted with distinct textures, lighting, and energy behavior that differentiate it from Hawkins. This distinction reinforces the metaphorical role of Dimension X, emphasizing alienness, danger, and the emotional response it provokes. Flickering lights, rippling air, and the distortion of familiar spaces communicate instability and unpredictability, aligning with the scientific principle that energy disturbances produce observable effects on matter. By rendering these changes visibly, the story allows the audience to perceive the stakes and understand the impact of interdimensional interactions on both environment and characters. Narrative pacing is influenced by scientific inspiration as well. The formation, expansion, and collapse of rifts dictate the rhythm of action and response. Energy buildup, environmental cues, and character perception create sequences where preparation, observation, and reaction unfold logically. These sequences allow the show to maintain suspense while demonstrating the causality of events, a principle familiar in experimental science. Characters must monitor variables, adjust strategies, and respond to feedback, mirroring how scientists analyze complex systems. The result is a story that feels methodical and deliberate, even amidst chaos, reinforcing the credibility of the interdimensional phenomena within the fictional universe. The writers also use Dimension X to explore collective experience. Multiple characters interacting with the same rift highlight coordination, communication, and shared perception. Psychic input, observational skills, and environmental monitoring converge to produce coherent action in response to unpredictable phenomena. This narrative choice emphasizes both the communal dimension of facing unknown forces and the human capacity to adapt. Scientific parallels exist in team-based problem-solving and environmental monitoring, where distributed observation and response enhance accuracy and safety. By integrating this principle into the story, the show reinforces realism and deepens character interaction. Finally, Season 5 demonstrates that the upside-down and interdimensional phenomena are more than spectacle. They are narrative engines. They provide challenges, reveal character traits, create suspense, and illustrate themes of fear, resilience, and adaptation. By grounding these elements in science-inspired detail, energy dynamics, environmental effects, and human perception, the writers maintain internal consistency and allow the audience to engage with the story as a plausible, coherent system. The symbolic and functional roles of Dimension X, rifts, and wormholes interweave seamlessly with character development, plot advancement, and thematic resonance, making the science fiction elements both entertaining and meaningful within the larger story of Hawkins. In the closing episodes of Stranger Things Season 5, the events surrounding Dimension X and its interaction with Hawkins invite reflection on both scientific principles and human experience. The series portrays the Upside Down as a place where energy, matter, and perception interact in unusual ways, producing phenomena that resemble theoretical constructs in physics while remaining accessible to a general audience. Rifts and portals, while impossible under known laws, are depicted with internal consistency. Energy flows, environmental responses, and human perception all follow patterns that make sense within the fictional universe. By presenting these patterns, the show bridges imagination with scientific inspiration, offering a vision of the unknown that resonates with curiosity, tension, and wonder. From a physics perspective, Season 5 draws loosely on concepts such as wormholes, space-time curvature, and multidimensional structures. The Upside Down functions as a mirror of Hawkins, governed by rules that are internally coherent yet diverge from reality. Energy concentrations form rifts, matter is temporarily altered, and time and space behave unpredictably. While real-world wormholes would require exotic matter, immense gravitational control, and would produce lethal tidal forces, the series simplifies these constraints to create navigable spaces for characters. Quantum mechanics and string theory provide additional inspiration. The idea of hidden dimensions, fluctuating energy, and observer-dependent effects are represented through psychic abilities, environmental feedback, and the mutable structure of Dimension X. The show respects the logic of these principles, translating them into visual and narrative elements that feel scientifically motivated, even if literal feasibility is absent. Human interaction with these phenomena serves as both narrative and conceptual grounding. Characters adapt, perceive, and respond to rifts in ways that align with known principles of cognition and sensory processing. Eleven's psychic abilities allow her to sense energy flow, anticipate spatial anomalies, and interact with portals in ways others cannot, illustrating enhanced perception under extreme conditions. Other characters rely on observation, environmental cues, and collaboration, demonstrating adaptability, learning, and problem-solving in the face of uncertainty. These interactions highlight the interplay between the unknown and human ingenuity, showing how exposure to unpredictable phenomena influences behavior, decision-making, and social dynamics. The narrative emphasizes that understanding, even partial, emerges through observation, experimentation, and adaptation, mirroring the scientific process itself. environmental consequences, as depicted throughout the season, reinforce the connection between interdimensional phenomena and physical principles. Flora and fauna respond to energy flows. Air and temperature fluctuate near rifts, and material objects are temporarily altered. These changes are not arbitrary. They demonstrate a cause and effect relationship consistent with the notion that energy interacts with matter. In real-world physics, energy propagation, feedback loops, and matter-energy conversion are complex and extreme. But the series abstracts these ideas to show visible, measurable effects within Hawkins. This abstraction allows the audience to understand the stakes and complexity of interdimensional interaction without requiring advanced scientific knowledge, grounding the extraordinary in observable phenomena. The synthesis of these elements produces philosophical reflections on human curiosity, danger, and the unknown. Hawkins is both a literal town and a microcosm of exploration, where discovery brings opportunity, risk, and revelation. Characters confront phenomena that cannot be fully explained, requiring courage, intelligence, and cooperation. Their experiences parallel scientific inquiry. Observation leads to pattern recognition. Repeated exposure produces adaptation and experimentation, whether conscious or emergent, yields insight. The Upside Down, with its alien landscapes, shifting geometry, and mutable matter, embodies the unknown that drives human investigation. It is at once frightening, fascinating, and instructive. By embedding human experience within scientifically inspired phenomena, the series portrays exploration as a synthesis of perception, reasoning, and imagination. Rifts, portals, and energy fluctuations function as narrative proxies for questions that drive scientific thought. Each opening challenges characters to anticipate outcomes, navigate hazards, and test understanding. Observing patterns, predicting effects, and responding to feedback are central to both the storyline and the representation of science. The narrative shows that even when direct control is impossible, systematic observation and adaptive behavior improve outcomes, highlighting the role of methodical inquiry in confronting uncertainty. In this sense, Hawkins becomes a laboratory, a site where curiosity meets risk and discovery is inseparable from caution. Characters' successes and failures mirror the iterative nature of scientific exploration, reinforcing the thematic connection between story and real-world inquiry. The series also reflects on the limits of perception and cognition. Dimension X defies ordinary sensory experience with distorted time, warped space, and fluctuating energy fields. Characters must extend their perception, rely on intuition, and collaborate to interpret phenomena. These experiences underscore principles from neuroscience and psychology. Human cognition adapts to extreme or novel conditions, using feedback and experience to navigate uncertainty. 11 exemplifies the enhancement of perception, while other characters demonstrate compensatory strategies through observation, pattern recognition, and shared knowledge. The narrative thus conveys that understanding complex systems, whether fictional or real, requires integration of sensory input, cognitive processing, and collaborative problem-solving. Symbolically, the Upside Down and its interactions with Hawkins represent the interface between known and unknown, safety and risk, normality and the extraordinary. The physical and environmental effects of rifts make abstract concepts tangible. Instability is visible, danger is measurable, and adaptation produces observable outcomes. Characters' engagement with these phenomena illustrates the human response to uncertainty, observation, adaptation, learning, and courage. The show's depiction of psychic energy, technological instrumentation, and environmental feedback reflects the scientific principle that systems respond to inputs in predictable ways, even when those systems are extraordinarily complex. The metaphorical and literal dimensions converge to create a unified depiction of exploration, risk, and understanding. Energy dynamics, as portrayed in the season, reinforce this synthesis. The flow of energy between Hawkins and Dimension X produces direct environmental and perceptual effects. Matter responds, ecosystems shift, and characters sense changes. While the physics are simplified, the underlying logic, energy interacts with matter and produces observable consequences, is scientifically valid. The depiction of these dynamics allows viewers to understand causality within a fantastical context, bridging the gap between imagination and plausible scientific reasoning. The sequence of energy build-up, portal formation, environmental response, and human adaptation mirrors real-world principles in physics, ecology, and human behavior, even as narrative requirements simplify or abstract details. The town of Hawkins itself embodies a microcosm of scientific exploration. Laboratories, homes, schools, and neighborhoods become sites of observation, experimentation, and adaptation. Human perception, environmental feedback, and the responses of energy and matter create a continuous loop of interaction. Characters track variables, anticipate outcomes, and adjust behavior, mirroring the empirical approach of scientific investigation. Dimension X functions as a variable, a source of data, and a force to be measured and understood. The narrative emphasizes that knowledge emerges through engagement, experimentation, and reflection, reinforcing the thematic connection between science and storytelling. Ultimately, Stranger Things Season 5 offers a layered synthesis of narrative and science. Dimension X, the upside-down and interdimensional phenomena, function simultaneously as plot devices, metaphors, and reflections of theoretical physics. Wormholes, energy flow, and matter interaction inspire the story, while character perception, adaptation, and collaboration ground it in human experience. Environmental changes provide tangible consequences, linking the fantastical to observable effects. The narrative highlights curiosity, risk, and exploration, presenting Hawkins as a small-scale representation of the challenges and rewards of engaging with the unknown. In doing so, the series demonstrates that imaginative storytelling can coexist with scientific inspiration, producing a compelling, coherent, and immersive exploration of extraordinary phenomena within a familiar setting. As the season concludes, the town of Hawkins returns to a tentative equilibrium. Portals collapse, energy flows stabilize, and the physical and emotional environment settles. Characters reflect on the experience, noting the limits of understanding and the power of observation, collaboration, and courage. The upside down, once threatening and mysterious, becomes a symbol of the boundary between knowledge and uncertainty, illustrating that exploration, even of the impossible, is an integral part of human experience. Through the lens of Season 5, viewers witness a convergence of narrative, science, and perception, a demonstration that wonder, curiosity, and adaptation are essential to both storytelling and the real-world pursuit of knowledge. In reflection, The depiction of Dimension X serves as a meditation on the human desire to confront the unknown. By integrating scientifically inspired phenomena with character development, environmental interaction, and narrative tension, Stranger Things Season 5 creates a compelling portrait of exploration and discovery. The series encourages viewers to consider the limits of knowledge, the necessity of adaptation, and the thrill of encountering that which defies understanding. Hawkins becomes more than a setting. It is a laboratory of imagination and observation, a microcosm in which the principles of curiosity, risk, and learning unfold in ways that are both entertaining and intellectually resonant. Science, perception, and story converge, leaving the audience with a nuanced appreciation of the extraordinary possibilities that emerge when human inquiry meets the unknown.